solution. He's particularly passionate about approaches that improve revenue protection while still strengthening trust between utilities and the customer they serve. Thank you so much for joining us, Mr. Warren. How are you doing today?
I'm doing very well, thank you very much. And I'm standing in for our Chief Technology Officer, Yael, who is unfortunately unable to be here because she's unwell. So look forward to it. Thank you.
Thank you so much. I think if we're using the normal tradition for Power Dialogue, this is the time where I announce housekeeping. But since we're all in our houses, I would say please hold your pen and your notepad tightly because this is going to be an impactful session. Um, the first question is focused on the big picture where AI actually meets the grid. So I will be starting with you, Warren. Um, Stemaco's IoT smart metering platform is designed to operate even in remote grid context. How do you see AI improving real-time grid edge visibility, operational monitoring, and loss detection in challenging environments? So this is looking at the big picture. How do we actually get this big picture to be printed in our real lives, in our day-to-day?
Thanks. The environment, and it's not just remote off-grid communities. It also extends in our experience to, densely populated urban areas. Data collection. If you're going to do something with AI, is going to be doing useful things with data analytics and producing, actionable insights. You've got to have the base data in the first place. And we run into a particular issue around the lack of infrastructure. So the lack of widespread metering, smart metering at this point. So, devices that generate the data. In the mini grid context, you have highly digitized networks already, where you've got like entire villages fully smart metered. In urban areas, it's still very haphazard. But, you need firstly the devices to collect the data, then you need the ability to communicate that data in as low a cost fashion. And you've got to balance needing lots of data on the one hand with also not having too expensive a cost to recover that data. I think it's also important to understand that there are going to be information gaps, data gaps. You're not going to have perfect operations all of the time. We definitely see an opportunity for AI through its ability to study data and learn that is going to become better and better at predicting and filling in the gaps with high accuracy. And that's going to help overcome some of these challenges in that we're not going to need to have 100% metering 100% of the time to be able to still get the benefits out of the data we can get. The other important thing, though, is AI is only so good. It does need to be paired with HI or human intelligence. AI can produce a lot of good information, directions, insights, but then it will need to be acted upon on the ground, particularly if we're looking at loss detection. We can pinpoint, and we've proven this, you can pinpoint to a house or a business where, a highly suspect case of loss detection or could be occurring. But if no one goes to check it, no one goes to check a faulty meter, you're not going to solve the overall problem. So you've got to pair AI with HI. You've got to act upon what it tells you, what it gives you, if you're going to get the full benefit from it. And ultimately, everything, you've got to balance the cost of employing AI, the cost of actually acquiring the data, processing the data, etc., with the value of the outputs. There's no point, applying a Rolls Royce to a dusty road that's full of potholes. So also adapting AI to work based on the cost needs is going to be really, really important.
Okay.
Thank you.
Thank you so much for that because key things I picked here is how important the initial data is, and now the financing, how we can now ensure we get the value for what it is we're trying to solve. And you also made mention of how the the cost and the value of the output have to be balanced, which now brings me to the next question. The person to take this question is Mr. Damilola. So my question to you now is, Warren has already laid the foundation on how those things can work. So my question now to you is, from your experience, can you share examples where AI implementation in smart grids or IoT-enabled monitoring has led to measurable energy savings? So he has said data is important. So now the practical example, because don't forget, we're trying to paint the big picture here. So how is this going to work from your experience, and what lessons can we draw from that? Thank you.
All right. Thank you, Busayo. Yeah, so yeah, he has laid the foundation. Data is the core for any artificial intelligence, practically any intelligence. And when we begin to look at how we can implement AI to improve monitoring, and energy saving, we want to look at how we can uh, use AI to first and foremost reduce ATC and C losses. And I think there's a company in somewhere in Lagos, right? I think it's Beacon Power, where they've been able to partner with some discos to use this AI to track and monitor their losses, and they've been able to significantly measure and monitor the losses. It has been reduced from my data. It's been reduced from about 35% to about 15%. That's for the Eco Disco, if I'm not mistaken. But when we begin to look at broader systems, like the mini grid systems, we've seen how companies like us using AI to save fuel, and not just electrons, right? So these guys operate in Nigeria, and they use AI and IoT to measure the predictive loads and manage the grids, which also is leading to some efficient saving of energy, right? And yeah, I think those are to monitor and measure significant impact, right? Like Warren said, you get the data, then we use the data to train these systems to make smart predictions. And with those smart predictions, we're able to in turn reduce losses and even monitor the whole energy system, right? Yeah, so I hope that's good. If you're speaking, Busayo, I mean,
Apologies. Thank you so much. And I like how you pinpointed how you use example of how like ETC and C losses have been reduced through the use of AI. And I know it's a common story in the power sector. One of the major reasons why we are not getting as much return as the investments we're making in the power sector is because of one of the factors is the ETC and C losses. And having this data being through the use of AI, the loss has been reduced from 35% to 15% is a very big plus. That's about 20% difference. So that's very applaudable. And now in the process of painting our big picture, we've done step one, we've done step two. Now is how we can actually scale up this process is to see that the picture is actually printed properly. And now my next question is to Dr. Abu Kadiri. So, sir, my question to you is, how is NERC preparing to ensure that AI integration into SCADA systems and smart grid is safe, secured, and aligned with national technical standards? So it's more of you have to actually give us the measurements, the standards. We've heard about how this thing is working on its own. We've heard about how we can get it to work better and the requirements the foundation, the requirements we need to put in place. So if we're going to mandate these things now, the AI, if we want to mandate the use of AI, what kind of technical standards do we need to put in place? What is required? And how is NERC preparing towards that? Thank you. Over to you, sir.
All right. Thank you very much, Busayo, right? And good evening to the listeners in the room. I think the first and the second speaker, they have laid the foundation, that is required to put us in the, or to give us proper understanding of the impact of AI in providing power system solution generally. So my discussion, like you say, is going to focus on how NERC is going to provide a regulatory environment that will support the safe, security, reliability, and quality of supply with the integration of AI and the SCADA systems, right? So to set that tone, it is very important for us to have a bit of a background of how grid operation in Nigeria has been impacted with lack of SCADA and probably what we're going to gain by integrating AI into the grid systems. So let me start by saying that the Nigeria power grid system has suffered a lot of system disturbance, which has resulted in either partial or full system grid collapse over the last few years. And then in trying to solve that problem as a country, the federal government of Nigeria, through the Transmission Company of Nigeria, started the development of a SCADA stroke energy management system and system telecoms project in 2022 to cover this gap. So the project is ongoing, and hopefully before the end of 2026, we should have the SCADA system up and running. But from the post-mortem reports that we got for most of the system collapse that has happened in the country, has always pointed towards lack of situational awareness as a major problem. So this SCADA project, therefore, is to resolve or to cover this gap that we have in our grid system operations as it were today. Now, to narrow down the discussion to the conversation we're having today, beyond the traditional SCADA system that we have, artificial intelligence, Internet of Things, cloud technology, and big data analytics are all emerging technologies in the 21st century that can help improve operational performance of power utilities. So it is therefore a great conversation that we're having today on the integration of AI into operational technologies. This discussion is timely and desirable at this time. I must say that before I go to answer the question. Now, back to your question itself, which says that how do we integrate AI systems into SCADA system? Now, the integration of AI into SCADA EMS system and smart grid is a convergence of what I call the operational technologies, information technologies, and AI infrastructure itself. And the overall objective is to improve the efficiency, the productivity, and the reliability of power system operations in Nigeria. So that is what we're aiming at. So in terms of what are the regulatory instruments that we have that will support this integration and deployment of AI into SCADA systems and other operational technologies like smart meters, IoT meters, telemetry, and all of them that we have going on right now. Now, specifically sections 12 and 20 of the grid code for the Nigeria transmission system has laid out the requirements for integration of SCADA system by all the grid users. So what I mean by all the grid users, that includes the generation companies that are connected to the grid, the transmission companies that are connected to the grid, and the distribution companies. They're all grid users. So these sections of the grid code has provided what the requirements are for them to be able to integrate into the SCADA systems. But beyond the traditional SCADA system that we have, because what you can get from the traditional SCADA system is what I can call static automation principles, so which means that data is being transmitted and then the feasibility is at certain intervals. But once you are able to integrate AI into the systems, which is part of what we are trying to integrate into the regulatory instruments that I talked about, which is the grid code and the Nigerian electricity supply and installation standards for the Nigeria power sector. So by the time you integrate the AI into the SCADA system, you should be able to transform the grid into an intelligent, self-learning system capable of anticipating failures, optimizing energy dispatch, and improving overall resilience of the grid. So essentially, with the recent review that we have done, there is a section that we have dedicated to what we call grid modernization. So this grid modernization will allow things like automation systems, integration of variable renewable energy, smart meters, and then intelligent electronic devices, which can make the grid operate more efficiently and reliably. Thank you.
Thank you so much, Dr. Abu, for you were very I like how you give us a background and now give us more context to how we can get this done. Particularly, you mentioned section 12 and 20 of the grid code. So for our audience, if you want to know more about how this can work, you can actually go back and read it alongside the NESI standards as well. So now we've somewhat painted the big picture. Warren has already given us a background to how these can work. Mr. Damola have also said, oh, this is the best way it would also work as well. And by listing out examples, and now Dr. Abu has said, oh, these are the requirements we need to do, and this is the possible benefits we'll see. For instance, now we'll have a more intelligent ability of translating data, translating issues or technical failures, whatever it is we want to translate in immediate sense. The next question is going to be on financing models. Now we've painted our picture. There's a common saying for our non-Nigerian, for our international audience, there's a common saying in Nigeria. It says poverty the kill idea. So what this is saying is when there's no money, the idea perishes. So now we've painted our picture. Now how do we finance? What kind of financing models do we need, or how best can we prepare the sector to leverage AI, of course, to get like proper funding to actually enact or implement this ideas that we've shared. So the next question is going to be to Warren again, because you're the VP sales, so you're the money man here. So my question to you is, given Stemaco's work in scaling digital metering and IoT across mini grids and utilities, what partnerships or business model approaches have you found effective for deploying AI-enabled meters and data systems in cost-sensitive or high-loss settings? Thank you.
Thanks. I wish I could say we've solved it. We have not. It is still very much a case of working our way through it with our utility partners, both big and small. I think one of the biggest constraints currently is the available funding being put into digital infrastructure is very much aimed at closing the metering gap, ergo buying the smart meters themselves. And yes, they're critical because they're ultimately the data generating devices, but there is very little support for utilities, large or small, to actually digitize themselves. Digitalization of a utility, especially a well-established one, is actually a very painful process. It's a whole new way of working with new tools. Business processes have to change. It impacts every aspect of the business, and our partners that we're working with do struggle. They are very much hamstrung by lack of ability to finance these changes, and that is the greatest sort of drag on the speed at which we can get to generating the benefits from digitalization, smart grids, and therefore then bringing the real benefits of AI. So better funding, specifically and aimed at the call it the software side, not necessarily just the hardware side, would be very, very helpful at speeding this all up. Partnerships are absolutely crucial. It goes as basic as the meter installation contractors need to adjust how they install meters. It's not just a case of put a meter on the wall and put some cables into it and check that it's powered and working. Actually commissioning it properly so it's communicating, it's tested as communicating, and it's connecting to the AMI software that is reporting to the head-end system. That is actually a crucial step. One of our partners has a less than 30% success rate, which then means additional time and effort spent going around fixing those installations to actually get those meters communicating. The next thing is partnerships between the utility and mobile network operators. That's actually crucial and probably overlooked. And making sure that the smart meters actually have got, if you like, almost preferential rights to constantly communicate as frequently as they need to. That is a massive impact on data collection. Some meters can sometimes go weeks without reporting. They can report, there's nothing technically stopping them, but their ability to report over the communication networks is severely constrained. And then the most important partnership between AI technology vendors, etc., is going to be with the utilities themselves. As I said, digitization of an organization, especially well established, is a painful and involved process. But ultimately, it's a hand-in-hand win-win situation when it works, and it's a journey that needs a very close working partnership between all the stakeholders involved. It needs to be properly funded, and we do need partnerships with the contributing teams and technologies, such as installers in communications.
Thank you so much for that, Warren. I think something that I got from what you have told us here is an essential part of getting a perfect financing mechanism or model is the kind of partnerships we make and how we intend to deploy the solutions. You mentioned partnership with mobile network operators, private companies, and AI technology. Also, I'm partnership with the government as well, because then we will be able to get like proper incentives amongst others. Also, if it doesn't, it also gives a better scope into understanding the vision the country has in actualizing your goal. Thank you so much for that. Dr. Kadiri, you're the next person I will be asking. So Warren has already laid the foundation to how partnerships and financing can best be done to paint the perfect picture. I'm still painting my picture for Nigeria. So yeah, painting the perfect picture. The questions I'm going to ask you now are regulations. It has to do with policies and regulations. So are there regulatory mechanisms such as tariffs, guarantees or incentives that could support the financing of AI infrastructure, particularly for smaller or rural distribution companies? So this is basically looking at the challenges that the 11 discos in Nigeria currently face. I think this question covers all of them. It doesn't have to do whether they're small or they're in rural communities, but like what incentives do we need, or what regulatory what tools based on the regulations that we have in Nigeria can actually support the things, the partnerships that Warren has already like shared with us to see how we can use AI to take the power sector to where we want it to be.
Thank you very much. I don't think there's anything to fear. We have sufficient regulatory instruments and arsenal for the discourse to leverage on in terms of adopting financing of AI infrastructure, specifically as it were. So as we're all aware, in the NESI, that's the Nigerian Electricity Supply Industry, the tariff regime that is being operated in the NESI is what I can call is based on the principle of incentive regulation. So incentive regulation normally is a regulation that is planned to improve efficiency of the operators. If you want to deep dive into it a little bit, it's more or less like what we call price cap and revenue cap regulations. That is the methodology that is used to incentivize the utility operators to be able to operate efficiently. So what it provides is that there's always an incentive for the regulators, and how it works is that there's a provision for rewards and penalties to induce utility companies to achieve desired goals. The good thing about incentive regulation is that the utility companies have the liberty to set what their goals and how to achieve the goals. But the regulator comes in the goals that they choose and how they achieve it is what we call like a menu of options. So it means that you select what you want to achieve, and then how all of this will have to fall within a price or revenue cap, and then you have to make sure that all the investment is within the approved price or service basket by the regulator for you to do that. So in choosing your goals, you can choose quite a number of things that you want to achieve. It could be smart metering that you want to choose to improve your performance and the efficiency of your services that you are providing to the customers. It could be technological innovation, which can be like AI, smart meters. It could even be something like a distribution generation that has to do with renewable energy at the distribution level. So all of this is something that is available and is very flexible for the distribution companies to choose the options, their goals, and how they want to achieve it, in as much as they stay within both the price and the service basket. So the regulator will continue to monitor the goals that has been approved, will monitor the cost that has been approved, and then efficient utilization of all the cost that has been approved for you. The most important thing is that there should be continue to be improvement in the service delivery to the customers. So if in their goals, if any DISCO choose in its goal to integrate AI into their services by developing some AI infrastructure, and it leads to efficiency improvement, well, that is fine. So there's that liberty for the distribution companies to be incentivized to go into AI infrastructure development. Thank you.
Thank you so much, Dr. Kajiri, for that. So what I'm hearing is these provisions have already been made to us and they're quite flexible. So it's just left for those who are interested to now actually look at it, examine it, also examine their goals and see how best they can make use of this instrument that is already being made available to Nigerian citizens. So when I'm saying Nigerian citizens, this is to expand the scope. So not just only people that have been playing in the sector. If you're also interested in playing in the sector newly, you can also take advantages or take advantage of the documents that we have, the regulation and policies that we have. My next question is to Mr. Daniel. So we've had the kind of things we need. Warren emphasized on partnership. Dr. Kadiri emphasized that the tools we have are already flexible and they're already available. So it's how to use them best. So in your experience, now what are the key barriers preventing private investors from engaging in AI-powered initiatives?
Okay, thank you. So when we look at the Nigerian ecosystem, power ecosystem, we see a number of, let me say, inefficiencies that would usually cause, let me put the word fear, with investing in the power sector, in AI-powered energy initiatives. First, I would want to point out is collection. There's no use if we have AI systems integrated, running fully, and collection losses are still accumulating. If an AI system saves the energy, the utility companies, the discos, must be able to collect the money from these people. And in a case where there's still some inefficiencies in this collections, then investors would naturally not want to invest because of the policies around it, the ability to collect returns on investment. Another barrier I would say would impact this investors commitment would be just like Warren said, communication, and that's the network infrastructure. If the meters are working, but for some reasons the network are not stable, then that poses another problem. We need to be able to have these infrastructures sorted, the network sorted, right? Because if there's a failure in transmission, then that automatically crumbles the whole initiative. Then lastly, right, I would point out the data infrastructure now. At the moment in the world, right, we have just very few leading cloud service providers. We know that this data needs to be stored on cloud services, and we don't really have home-based, Nigerian-based cloud providers who would be willing to host our data. Because according to the Nigerian Data Protection Act, we are supposed to host personal data, customers' personal data within our systems. But in a case where we'd have to push all our data to AWS, Azure, that becomes some policy bias, right? So looking at just this three points, that's the collection, liquidity and collection barrier, the connectivity infrastructure, and the current data infrastructure that we experience in Nigeria. This will most likely lead to uh, barriers and prevent private investors from engaging in AI-powered energy initiatives.
Thank you so much for
Thank you.
that. I think the one you made mention of on communication, I think that one sticks out to me the more because um aside from even this topic, the general part of Nigeria, like there's a communication barrier, conflict of data, etc. going on. So we actually need to get all of these things sorted before we move to saying, oh, we want to have a stable, power sector using AI. But then before we move on to the next theme, I want to ask all my panelists. So it's what is more difficult? Is financing more constrained by the cost of technology, the lack of data, or regulatory uncertainty? So who would go first? Okay, Mr. Dabla, you're already here, so let's start with you.
Okay. So these factors you've mentioned, they are all very critical to adopting AI to improve the energy sector. In my own opinion, I'm not even going to say one is better than the other
Yeah.
because the data has to be available. It's just like we are making a soup, right? Without the proper ingredients, without the presence of all the key ingredients, we'll be making a concoction and not a soup, right? So I wouldn't pick them in isolation. But because of my bias as a data scientist, I would prioritize the data. No, first, without the data, there is no machine learning, there's no intelligent system. And until we get this intelligent system, until we get it right from the basics, any other thing we want to do is not, there's no even foundation to build on because we need to be building on the data as a foundation.
Thank you so much. Mr. Warren, do you want to go next?
So financing is an interesting one. If anything is holding back availability of financing more than anything else, it's two things. One is just the sheer bankability of the discos. Trying to work with them and organizations like IFC,
Yeah.
it's tough, right? It's tough to pass the due diligence. Secondarily, then the next thing is if financing is approved, it's financed at Nigerian interest rates, especially if it's coming from multilateral lenders that gets funneled in through the country. So then, discos can't enjoy, they can't raise funds in the international market and pay international exchange rates, interest rates. So those are the real big challenges. It's not like the money isn't there, but it's getting it approved and dispensed and at a cost that's not too onerous based on the benefits. So financiers are interested, however, in having access to the data, the process data, to sort of as a insurance that they can actually see then that the revenues are being generated, losses are being reduced, that they are going to get paid. That then actually de-risks, but we haven't quite yet crossed the line where they start going, yes, this is definitely a way to de-risk, and therefore I'm willing to ease up on my requirements to extend finance.
Thank you so much for that. Dr. Kadiri, so what do you think? Should we prioritize tech? Should we prioritize data or regulatory uncertainties? Which is more expensive?
So thank you very much. If you ask me, I think I would say all three. But in terms of ranking, I agree with the last speaker. Cost of technology can be a major problem. In terms of data is also very important. So, and data is a major problem as far as we know in this country, especially in the power sector. So those two are very critical. But in terms of regulatory uncertainties, yes or no, in the sense that the regulatory and the required framework, to support the deployment of AI infrastructure is um, is something that I think is available, from the flexibility of what I call the incentive-based regulation that I discussed earlier on. But where a bit of the regulatory uncertainty or policy support, let me say more of policy support, is that now for you to have this basket of service and the price, that is allowed in incentive-based regulation, it means that you need to have full cost reflective tariff, because we have a network architecture that is in a very dear need for enforcement and expansion, and then you have a whole baggage of issues that you need to resolve, issues around network reinforcement to make it reliable, issues around substation upgrade, and then issues around providing the right protection equipment to ensure that the power supply is safe, is reliable, and is secured, and the quality of what is coming out of the the stations are good enough for customers, especially industrial customers, for them to be able to use our grid power supply effectively. So if you do not have a cost reflective tariff that is implemented, implementation is the issue. The framework for cost reflective tariff is in place. Now, allowing full implementation of cost reflective tariff is very expedient for the revenue that is required by the utility operator. So it is when the utility is armed, the utility company is armed with the required revenue, that it now begin to look at what I called earlier on as um, menu options, that you have to look at what is my priority. Am I going to go into metering? Am I going to go into reconductoring? Am I going to go into substation, or am I going to go into a deployment of emerging technologies like AI and all of that? So that was, I say that in terms of ranking, the regulatory uncertainty is low, but the part of it that is very significant, or that is very important to the whole of this discussion that we're having, is the issue of policy support to ensure that we drive towards implementation of full cost reflective tariff. And then we can begin to talk about technological evolution that can improve the efficiency of our operations. So thank you very much.
Thank you so much, sir, for that. I think everyone has chosen. Okay, it's 2 for 1 now, with a little bit of regulatory uncertainty. So we have Dr. Kajiri supported the cost of technology, but he also made mention of how the policy support is very essential, especially looking at how we can get like cost reflective tariff. Mr. Warren also made mention of the cost of technology. And Mr. Dama also, he already said he was biased because he's a data scientist. So he went with data. And at this point, I'd like to tell my audience that please start preparing your questions, your contributions, your comments. After the next theme, we'll open the floor for questioning and answer, and then we'll go back to the conversation with the panel. So the next thing we'll be talking about is the policy, the regulatory environment to strengthen the policy, regulatory, and institutional environment for secure, standardized, and scalable AI adoption. So the person that will start on this theme is Mr. Damola again. So what policies or regulations are critical to ensure secure and standardized AI adoption in Nigeria's power sector? Thank you.
Okay, thank you. So what policies or regulations are critical to ensure and standardize AI adoption in Nigeria's power sector? First, I would say mandatory meter data standards. Because like I said, I'm biased towards the data, right? Currently, Nigeria suffers from vendor locking. Different discos have different meter vendors with different softwares. So what that means is the data sits in different silos. First and foremost, we need to break those silos and find a way to sort of unify the data that we collect so that we're able to not just even learn internally, we're able to invite external participants to look into the data, build AI models to optimize this data and produce better solutions. Another that I would say would be the the impact of cybersecurity. Because once we begin to do a lot of internet online processes, we become exposed to online hackers, and we do not want a situation where they are hacking into this data, manipulating the data. That would be a serious breach. So we need to sort of make guidelines that enforces cybersecurity such that it protects the whole transmission of the data flowing online. We need to draft policies around that. Then lastly, right, would be data localization. I think I'd mentioned some part of this before. From the Nigerian Data Protection Act law, we do not want data leakage. We don't want data breach. We want to make policies. We want to be looking to make policies that can properly embolden the data localization such that there's no breach of data. So in a nutshell, what I've said to answer your question that on policies and regulations that are critical, we need to start looking into policies to make a mandatory metering standards where all the discos are in somewhere. Also, policies that improve the governance that cuts cybersecurity threats. And lastly, policies that would ensure that private data, customers' data are securely protected. They are not used for third-party unrelated events, right? I believe with these policies in place, it would embolden the AI drive for Nigeria's power sector.
Thank you so much, Mr. Damilola. 3 points you mentioned: unifying data collection in a way that we can learn both internally and externally, data localization, and making provision for cybersecurity to ensure we don't to skip over data manipulation amongst many other cyber crimes. So that's very precise for especially looking at the Nigerian context. So the next person to answer this question is going to be Mr. Warren. So from your experience what technical or operational challenges often slow the deployment of AI-driven smart metering and grid systems, especially under-resourced markets? I know Mr. Damla has already laid foundations by listing some of the challenges or some of the things we need to do, but I'm sure there are other things that you have faced or Stemaco has faced in deploying this AI smart metering. So what kind of things often slow the deployment of AI smart metering? Thank you.
Okay. As I said before you can do, cool stuff with the data using AI, you need to get the data. And that means how smart meters themselves are being deployed. Quite frankly, it's a scattergun approach. It's based on the MAP program. It's based on, where utilities decide or the discos decide that, the choices they make as to who gets a meter if they're rolling out the national mass metering, the free meters as we call them. And what you end up having is you've got DT clusters, you've got feeders, etc., that with haphazard metering, and you've got a large number of connections that are still in estimated billing. And it creates lots and lots of data gaps. And, even with our utility partners that are rolling out right now, trying to fix that so that we actually are getting enough data sets within a geographic area, say around a DT or along a feeder, for the AI models to actually be beneficial and actually produce, better results. It's difficult when you've got, maybe 5%, 10%, 20% of the connections metered in that area. And you have a lot of unknowns around that. So adapting the metering rollout strategies is going to be fundamental, particularly as the various meters are being delivered under DISREP and NMMP are being deployed in the PMI are being deployed, it actually needs to be done hand in glove with the AMI provider, Steamaco, Beacon, whoever, because if you're going to get the benefits out of just even the smart metering platform, let alone AI on top of that, it's got to be done in a more methodical fashion that's actually beneficial to achieving the aims, the business aims of the utility, as well as the technology aims of the utility for the tools that they're employing. Ultimately, it's a difficult one because we're a solutions provider, we're a technology provider. We've been piloting AI. We're getting into contracts originally because we want to do the fun stuff with AI. But the reality is, fast forward a couple of years later, we're helping arrange financing, we're helping correct installation problems, we're helping utilities just digitize their teams, we're helping utilities try to understand how to, there's a lot more that we have to do in order for us to even be able to begin to, focus on the cool stuff around AI and actually helping the utility derive the real benefits from that, because there's a lot more you've got to correct. Fundamentally, you need the digital infrastructure in place, and it needs to be working and it needs to be communicating. And there's a big gap right now. You don't just throw smart meters into the market. There's a big gap in making sure those things actually work in the way they need to work before you can do the cool stuff. And that's still a problem to be fixed.
Hello, just a minute. Busayo is having a little technical issue. She'll join shortly.
Apologies. Can everybody hear me now? Apologies. There was a glitch in the internet.
Yes.
Yes,
Can
we can hear
everyone
you.
hear me?
Yes, Blessing.
Thank you so much. I think I'll just put off my camera to ensure stability for now, pending when I get it sorted. And apologies for the delay. So I think I've gotten the point of view from Warren, from Mr. Damilola, and now is Dr. Kadiri that will be sharing the next insights. By the way, we have lots and lots and lots of questions. I think a lot of people are very interested in this topic. So, Dr. Kadiri, the IEA's Energy Efficiency 2025 report highlights accelerated global adoption of digital and AI solutions in electricity systems with strong policy and regulatory frameworks, enabling measurable efficiency gains. So in this context now, what steps in NERC, what are the steps NERC is taking to strengthen Nigeria's regulatory environment to support secure, standardized, and scalable AI adoption in the power sector? I know you already mentioned some of them. The previous top themes spoke about like the flexibility of incentives, the regulatory section. You even mentioned some of the regulatory section, but what precise steps are NEC taking to ensure secure and standardized AI adoption in the power sector?
Yeah, thank you, Blessing, and welcome back after the short break. So I will just take a cue from where Mr. Damilola and Warren. Mr. Damilola essentially gave insights on the policies required, and then Warren spoke about issues around the technologies. So straight on, I think I would just like to speak about the regulatory instruments that we have to support this scalable AI adoption. So, and like you pointed out, I've discussed quite a number of them in the first instance that in the first question rather. Let me say it here that the Commission has been working very assiduously to ensure that we have the regulatory instruments that is required to deal with all the emerging technologies in place. As we speak, the metering code has been reviewed and approved and published, right? And a key component that has been integrated into the new metering code is standards and specification for smart meters. So that is very essential to this conversation that we have in terms of technological innovation. So we have a new metering code that is now comprising emerging technologies, smart meters, IoT meters, and all the specifications that will be required for clarity of implementation of the various metering initiatives. And the other two are also at advanced stage of completion of the review. I did mention that we have the grid code, for the Nigeria transmission system. The review NEC work with key stakeholders to review that document, and these are also at final stage of consultation for us to publish the new editions, and also the Nigerian electricity supply and installation standards. So, like I mentioned earlier, a key area that was considered in these two regulatory instruments are issues around grid modernization and the system automation. So, which allows the incorporation of quite a number of the emerging technologies that we talked about to make the grid smart, to make the grid more efficient, more reliable, to provide the services that is required to the customer. The key elements that are contained in the new amendments include issues around integration of variable renewable energy, like I mentioned earlier, standards for smart meters, which is contained in the metering code, automated systems, and very importantly, as I mentioned, a key issue that we need to deal with, and as much as we are very much interested in technological advancement and integration of the emerging technologies, is cybersecurity. So all of those things are contained in data analytics and AI infrastructure. So we have quite a number of these regulatory instruments that supports the scalable AI adoption in the power sector. Thank you.
Thank you so much, Dr. Kadiri, for that. Now we're going to the first round of the question and answers. So, well, we have a lot of questions actually, but we're going to take them so we don't use all the time to answer questions. We're going to take them like step by step. So, the first question is from Olubowale Songo Sonia. I hope I did not mispronounce your name. Forgive me if I did. So this person asked, how can AI driven energy optimization reduce and operational costs, system losses, and downtime across the Nigerian power sector value chain. I think that question should go to Mr. Damilola and Mr. Warren. So who would want to take it first? Mr.
Okay.
Damilola, you're muted if you're speaking. Okay, thank you.
Dami first.
All right. Yes, so I'm just going to focus on one, which is reducing the ATC and C losses. We know that with AI, we're able to build smart systems which can predict when there is possibly energy theft or when there's going to be a snap in the grid. So if we are able to build intelligent, not just build and implement these intelligent systems, it can directly tackle, at the very least, begin to reduce these losses that we might experience. Thank you.
Thank you so much for that. And Warren, do you want to go next? Okay, you're going next. You went first.
Sure. The high value problem to solve are the losses. It's where you've got to start. The second part, though, is operational costs. Quite simply, when AI is saying field force, this is where you need to go. Here's your day plan. It's being generated on the fly. It's dynamic, and people are being efficiently directed to do the job that they need more efficiently. That means their time is being used more effectively. Therefore, your operational costs are reduced as well. So there's a double benefit, right? Increased revenues from reducing losses, but also reduced costs from using your workforce more efficiently.
Thank you. Thank you so much for that. The next question, I would like this for everyone actually, but I would like Dr. Kadiri to start. So the next question says, what is your advice on how to use AI for data gathering and harmonization in NESI? They realize that data has been one of the major problems facing NESI. And I think Mr. Dama mentioned the need for unifying data harmonization. He already made mention of that. Dr. Kadiri made mention of how the policy is already there. It's just left for the interested persons to take advantage of these opportunities. So, Dr. Kadri, I want you to go first.
Thank you very much. So, we all know, AI actually have two basic solution methods, which has to do with the machine learning or the deep learning solution method. And in the machine learning solution method, there's quite a number of algorithms that is used to. But the good thing about it is that it's in terms of data gathering, it is has a very high level of capability and speed to deal with this issue. So it's a more efficient way of gathering data. And then in terms of data integrity, is also highly placed, than the normal traditional tools for data gathering.
Thank you so much. Thank you so much for that. The next question. Okay, the next question says, Yes, how was EcoDisco? I think this is from Mr. Damilola. It says, how is EcoDisco able to use AI to reduce ATC and C losses? On what part of their infrastructure was it employed? And was it deployed in all their area? And was it deployed in all their coverage area? So this is from Ridwan Yusuf.
Oh, all right. So while I may not necessarily have the full context to how they have used it, I'm aware that they have partnered with it. You can just even research this on Google. They have partnered with a startup, right? Beacon Power Systems, and this Beacon Power Systems are built about 3 products. So they've utilized AI models to map out the grid and detect anomaly in real time. So with this BPS technology, I think it's there's one of the product they call Adora. It allows this utility to say exactly where the power is flowing versus where it's being built. So that way they're able to pinpoint leakages, theft, with a very high precision. But you can as well look up it's on the internet for more details. But I'm aware they partnered with this company. And there are some other companies right out there that are able to partner with Discos to use AI to solve their operational problems.
Okay. Thank you so much, Mr. Damilola. So we'll go back to the panel session now. I just needed first take some questions right now because I didn't want it to be a lot at the same time when we have concluded the sessions. So the next theme is going to be on how to explore data systems and smart meters to support decentralized energy solutions and customer-centric models. So I've read some articles, I've done some research, and I think from the consumer point of view, they believe that the consumers are not being fully represented when we're designing some of these technologies. It's more of how do we get the money back? How do the investors get the money back? How do the government? How do they make their profits? And every other stakeholder, but then the consumers, they're not at the heart of this conversation. So that's one part of it. And the second part of it is now like how do we align development, finance, and innovative policies to accelerate the deployment of AI solution across Nigeria's power sector. So he's talking about the last question, this is the last set of questions, by the way. He's talking about how do we make the services more customer-centric while deploying financing models and innovative policy to ensure everyone is satisfied in the power sector. So Dr. Kadiri, you'll be going first. The question here for you is, how can NEC ensure that smart meters and grid data are used effectively for energy efficiency while protecting consumer rights and privacy?
Wow. So thank you very much. I think as we're all aware, the Commission has been promoting accelerated metering initiatives, working with other stakeholders in the power sector, and these initiatives includes the deployment of smart meters, smart metering systems, and automated metering infrastructure, AMI, for customers, and grid metering. The goal of this is to establish visibility of energy consumption by the customers themselves so that they can monitor what they consume and they can plan what they consume within the envelope of what they want to pay, so it gives them the opportunity to be able to control their consumption vis-a-vis their capabilities to pay for what they consume. And then it essentially monitors, like I said, the consumption, and of course, that is at the customer level, and then transaction at the grid metering level. So this will reduce commercial losses, as it were, and also improve energy efficiency, right? Because loss reduction is a key component of energy efficiency.
Thank you so much. So again, I would want to go to Warren next. So, how can meter data collected by Stemaco smart meters feed into decentralized energy planning, improve demand forecasting, or support customer-centric services, e.g., usage insights, flexibility of tariffs, what and whatnot?
Thanks. To echo a point made earlier, to have the best and greatest benefit for Nigerian consumers, the aggregation of data, breaking down the silos. Right now, what you have in the market is every utility, be that a disco, be that a mini-grid operator, or someone in between, is operating their own systems, their own data. It's there. So even one utility can have a really, great AMI and AI system in place, but that data isn't available really beyond that. I know there's moves to try and centralize, but really, if you're going to really unleash the power of AI, but particularly the innovators who can create, really cool AI benefits for consumer, or AI-driven benefits for consumers, they need access to that data. I mean, here in the United Kingdom, we've now got, if you like, a national MDMS where all the smart meter data goes there. You can have virtual utilities. You've got apps. I mean, there's a great creativity that's very beneficial to consumers. once that data is shared. And that really needs to be like the ultimate goal in Nigeria: break down these walls, these silos, and get that data into one place so that, really cool stuff can be done with it for the benefit of consumers and by consumers. I want to make a point as well that to sort of when we talk about Steam Eco smart meters, yes, we have sold smart meters, and we manage smart meters, but we're not the only one. It's important that these data from all the different smart metering systems being bought and installed, etc., across Nigeria, when that data is collected in secure places, it can be anonymized and passed then to AI models. It's not like AI needs to know everything about everyone in order to deliver great benefits. So, for example, passing anonymized data over to AI models, letting it process that and kick the outputs back into secure, locally stored repositories, who then make the link between the output and, say, the consumer or the meter that it refers to. There's ways to make this happen in a way that it also is going to protect the consumer. From our perspective, once you solve the losses problem, you then start looking forward to how consumers be more energy efficient. How can they control things on the fly? How can they top up, their grandmother's meter from across the country, from across the world? There's so much more we can do once we've got the infrastructure in place, and we're able to get that data into one shareable spot, but process it safely.
Sorry, Busayo, you are mute.
Apologies again. Apologies again. Thank you, Mr. Demola. So I was saying that I'm picking up points from what each person is saying, because I'm trying to make a connection at the end of this theme, right? So before I ask the next question, Mr. Demola, are there examples where AI and smart meter data have significantly improved operational decisions or customer satisfaction?
All right. Yes, so I believe so. Based on my research, the TCN their team have sort of built a in-house IoT solution to monitor the grid while they're
Yeah.
waiting for the bank funded scale-up project. This system is able to, this data-driven approach allows them to improve visibility from 6 to 27 generation stations, which improve operational efficiency significantly. Another example would be the customer satisfaction at the Ikeja Electric Disco, where they have leveraged data from smart metering infrastructure to segment customers efficiently, right? Identifying high value clusters for bilateral power agreements. Another example where this has been used, would be the first example I had shared, right? The EcoDisco, where they have used AI for energy theft detection, where they're able to predict where exactly the energy theft is happening. And that way, like what Warren also said, they're able to deploy their resources operation more efficiently. They're able to send the field workers to these locations, and it's likely with a very high level of accuracy. And in all these cases, there are examples where AI and smart meters have significantly improved operations and decision making from TCN to Disco.
I'm
Yeah.
muted again. Thank you
Yeah.
so much for that. Before we go back to the next round of question and answers, do we think that to an extent is because of maybe little level of knowledge that the consumers have on how to use these technologies also contributing to their dissatisfaction?
Sorry, I didn't get that.
So I'm saying some of these consumers, especially maybe those in rural communities, I've read some report that they've been deployed with smart meters have been deployed in these locations, what is and what not. But then they do not know how to use it. They do not know how to read into what it's saying and all of that. Do we think this could also affect their satisfaction? The fact that they don't know how to use these technologies.
If I may, from the mini grid context, I haven't picked up consumer from our customers, the mini grid developers who use us. Consumers going to complain more about that the energy they bought hasn't, the meter's not on and they're not getting their lights, or that it seems to have gone faster than they thought. And that's really where the disconnect maybe comes in, is not being able to understand or see easily what the actual consumption patterns are like, or getting tiniest warnings in time. Part of that is, we're all very used to having a phone with an app on it, but not everyone has a phone that can run an app, or it's going to be a very basic. If they have a phone, it's going to be a basic phone that does SMSs. So maybe more focusing on making sure that we've got adaptable solutions that can work with different kinds of consumers in different environments, and based on their ability to access tech of any sort. Or at least make sure that someone who's on site serving the customers has got the ability to actually look into what's going on with the customer account. Your consumer is going to be very, very diverse, and it's making sure that the solutions we deploy can actually fit this great diversity in consumers.
Thank you. Mr. Damila, do you have anything to add to that?
Warren already laid the foundation. We, especially in Nigeria, we have a very diverse user base, customer base, with a very high level of illiteracy, if I would say, right? So in many cases, they do not even understand what they are doing. They don't even understand the system. So which could lead to being dissatisfied with the service. But when we're able to create solutions that meet them at their level of education, simplify it either through their feature phones, and communicate what exactly they have access to and they do not have access to. That might go a long way in improving their satisfaction. But I do believe that the bulk of the smart AI implementation will be happening on the Disco side, on the provider side, metering side, because we are the ones with the large resources, the data infrastructure and all. And if we are able to now work together, from the Disco side, or let's say the government side, create a more simple solutions that meet these users at their point of needs, possibly even have it in their local dialect manuals, so they're able to read and understand. That would go a long way in improving their satisfaction.
Thank you so much. Thank you so much, Mr. Damila. Dr. Kadiri, how about you? What do you have to add to this?
Sorry, I was muted. So I think they have put the conversation in right perspective. Maybe what I will add also is that the AI deployment, as it were, also is very key. Not just the distribution level, but both distribution and the transmission level. And you understand that from the perspective that whatever happens at the transmission level, especially for grid connected services, affects all the distribution companies. So it is going to be more or less like a technology that is required across the value chain. But just like Damilola said, except where you have distributed generation at the distribution level, so you can also have the AI solution. But most importantly, the literacy in terms of adoption of the AI is also very important for the customers. And now that we're deploying smart meters, but what I try to contend with is whether we require smart meters at the minute village or remote villages. If you look at the cost of the smart meters and what is the consumption or the bill or the revenue that will be generated from the smart meter. So these are discussions and conversations that we can look into it when we try to come up with what I call a coordinated metering policy going forward. Because what we have today is that there are quite a number of interventions that are going on. Like you see, the NMMP, which took some few years, that started some few years, the PMI, the MAP, and even the World Bank PMU procurement of all the meters. But in going forward, I think it will be very critical for us to have a policy that coordinates the type of technology, metering technology or metering systems that will be deployed in urban area, peri-urban area, and then in townships and villages and even further down remote locations. I mean, Mr. Warren talked about mini grid systems and all of that. So for
Yes.
such customers in very remote areas, I'm not sure that what they will require will be smart metering, in terms of when you look at the cost profile vis-a-vis even the consumption profile and all of those things. But that should be a conversation for another day, right?
Thank you. Dr. Kadir, I think you've low-key asked the other panelists a question. So do you guys think that the people at the remote communities or minute communities need smart meters looking at their consumption? I want to hear their thoughts on that as well.
So, please, can you see that again?
So I was taking from your point on how you made mention of how you're uncertain if people at the minute level or the remote communities need smart meters looking at the consumption of their energy consumption. So I was asking the other panelists that do they also share this thoughts or do they think they also need smart meters?
So we should
Warren, I
hear
think
from
you
them,
should
right?
go.
Yes, yeah.
Warren, I think you should go first.
Well, I did make this point to the REA at one point when I was there early this year, in that the whole electrification program does sort of require smart metering tech be deployed, including in deep rural communities, and it actually gets more expensive the more rural you get, particularly if you've got to start looking at things like Starlink for communications. And there's no real support for those communities or the operators of mini grids in those communities. So smart metering isn't a one size fits all. If you want high tech solutions in areas where there's low ability to use and pay for energy, then there needs to be greater financial support for the people that are delivering the energy service there to meet those standards. So even within our customer base, you've got connections that maybe the utility doesn't need a meter read more than once a week, and other connections they want a meter reading every 15 minutes, and it's based on the level of service and the consumption levels of their customers. So there is a great diversity in consumers, and therefore the metering deployments really should take into account that great diversity and fundamentally the ability to pay, because too many mini grids are at risk of failure right now simply because they are financially stressed. And they're lumbered with the smart metering system and the cost thereof, and they're not making enough money. So there's a need to look at what fits best where to what purpose.
Thank you so much, Mr. Damilola. Let's hear from you. What do you think?
All right. So, based on the current terrain, the reality of the Nigerian space, it's gonna be very expensive to deliver smart metering to each and every single house, and I'm talking in the most remote areas, which doesn't look feasible, at least not yet. But maybe if we go via Dr. Abu's implementation, strategic rollout of these meters, we might be able to solve that. But at this current time, I would recommend that we probably implement the smart metering. Now, for this remote areas, right? We implement it at the DT levels or even at I think DT is the distribution station, right? So we implement it at the DT levels to just give a aggregate of the whole community. And as we continue to advance and bring about more awareness and adopt these AI solutions, we can now begin to go granular. But for now, I totally think we should just focus on the urban and semi-urban areas for the smart metering. Then for the very remote areas, we do a DT sort of smart metering in this case.
Thank you so much. Thank you so much, everyone, for that. So now we'll go back to the audience and get their questions. This person, Olubowale Shongo Sonya, again asks, what methods exist today to securely breach data from level 3/3.5? Forgive me if I murder your terminologies, DMZ, into the cloud or AI analytics platform without violating the Purdue model? I don't know who that is for. I think it's leaning towards Mr. Damilola. I think it's yours.
Yeah. When the question is so technical, but amazingly, I'm not a completely power technical expert, right? But from the aspect of data, if I get the question correctly, say what system exists today to move data the from
Level
the
3?
entry point
Yes.
to the cloud to move from one
Yes.
point to another. All right.
Yeah.
So there are some data engineering tools or cloud data engineering solutions that is able to move data at scale, be it streaming data. That means as the events are occurring, moving the data and storing it securely. There are different platforms, right? There's the Databricks platform, there's the Apache Airflow and the data warehouses where we're able to build data engineering infrastructure to essentially move data from the different touch points to the centralized location, which would now be built upon trained for the machine learning and the predictive analytics. Yes, those platforms too would also help with deploying the systems so that it's not just a trained data on the cloud, it's also functional, and the different stakeholders are getting value for their money.
Thank you. So Olubowale also says that Mr. Warren can answer this. So I think he also wants to hear your thoughts on this topic.
So, I think the clues in my title, right? VP Sales. I'm certainly not a software engineer, but I've dabbled enough, and you know what? AI is really helpful. I've just did some Googling because I know what the Purdue model is. From a cybersecurity point of view and protection point of view, something that I think is important to understand is there's DLMS COSIM protocols, which are generally used worldwide, which include a high degree of encryption, sort of AES 128, etc., which, if employed by the metering manufacturers, will go from meter to the gateway, comms gateway, and protect it through the internet to the cloud service, or the simultaneously, if it's going to a locally based head-end system, and then that system is converted to a local MDMS, and then those systems are connected to a cloud-based AI platform, the cybersecurity can be architected at those layers. I would say, though, there is a case where there are many cheaper meter OEMs are using non-protected protocols from, say, the metering device to the local gateway, or even up to the head-end system. Only then is it sort of within standardized encrypted protocols like DLMS. So in terms of making sure that data is protected from the device all the way through, that's a function of ensuring that metering codes and encryption standards are being adhered to by people building and importing meters in Nigeria. Simultaneously making sure that when data is moving from safe repositories within the control of, say, DISCO, or within the borders of Nigeria to cloud processing systems, that those requirements, the protocols, etc., are well defined and being monitored and being checked as being adhered to.
Thank you so much for that, Warren. So the next question is from Chidimali Dalby. She's also a consultant at Nextyear. So her question is, how best can we invest in research and capacity development to ensure that we use artificial intelligence to have energy accessibility, affordability, and stability in Nigeria? Who would want to go first? Dr. Kajiri, I think you should go first. Should I take the question again?
Please.
Okay,
Yes.
the question is from Chidimali Daobi. Her question is, how best can we invest in research and capacity development to ensure we leverage artificial intelligence to ensure electricity affordability, stability, and accessibility in Nigeria?
Okay, right. That's a very good question. Continuously as a commission, we have been involved in supporting quite a number of research, and we have good collaboration with also academia. So to ensure that we can continue to improve, innovate, to adopt technological solutions that can improve both service delivery and also the cost of a service, like she said. So this collaboration is going on. Also, our own staff are also involved in very high level of capacity building and research work. So it is something that is very critical for us to be able to make progress in our regulatory functions. So the collaboration with the academia is something that has been going on since as far back as 2020. And every time we identify key areas that we think that research has to be conducted, so we try to liaise with the people in academics, and then we usually do a hybrid of people in the academic space and also people that are very experienced in the industry. And sometimes we also get support from other international development agencies like DFID, GIZ, and USAID, and all of those things. So they support us when we think that we need such research and then capacity support.
Thank you so much. Thank you so much, Dr. Kadiri. Mr. Damla, do you want to go next?
Yes, sure. So a way I strongly believe AI can improve the whole value chain for power is with the accessibility to the data, accurate data, because in our climb, we see having accurate data as a serious limitation. So in a case where we're able to have publicly available accurate data of consumption, of distribution across the GenCos, across the nation, that way we can draw the attention of more researchers, more AI researchers to begin to study the data. It could even be through hackathons and different programs to ensure that we're able to bring in both internal, local engineers, foreign engineers, international engineers to begin to wrangle the data and build intelligent systems around it. I believe this will strongly, because of the competitive nature, right, of the hackathon, right? People are trying to build the best models, trying to build the best solutions. That would accelerate the adoption of AI. But it all starts from the data being publicly available. Okay, I keep saying the data. I should put accurate data being publicly
Yeah.
available. Yeah, because
Yes.
access to data is a big challenge here. Thank you.
Thank you so much. I think that's all for the questions, so we can start rounding up. Key takeaways from this session. Thank you so much, my panelists. You've done justice. We've learned intelligently from each and every one of you, from your diverse field, coming from the finance, the data aspect, the technology aspect, and even the regulatory and policy aspect too. So I deeply appreciate your presence today. So, but key takeaways that we've gotten from this session is, first of all, from the regulatory point of view, you need to know the regulatory policies in your country. So Dr. Kajiri have said that these things are available, the incentives are there. You just need to read it and understand what it is, if it fits into your goal, and how to make best use of it. He specifically mentioned section 12 and 20 of the grid code. So everybody here, tell a friend to tell a friend, go and read section 12 and 20 of the grid code if you want to take advantage of this incentive. He also made mention of how it's very important for data translation is very important. So the NEC is already regulated. So the connection between the consumers, the discos, and transmission company, every other person, we also need to work in a unified form to say that, okay, the data we're using in A is what we're using in B, is what we're using in C. Mr. Demna said accurate data. So so we shouldn't be more with funny figures just because we're just trying to get something done. We need to do it properly. A highlight from what Mr. Warren made mention was the cost of value and the outputs when it comes to AI. You need to measure these things from the financier's point of view. They always want to see data, because if they don't see data to back whatever it is they're funding you for, it's looking like free money, and they'll rather use that money to do something more important than invest in your product. So you should be able to back to data again. You should be able to give accurate data. Mr. Danola already made mention of how it is very important to unify data. Data localization as well as cybersecurity. So the reason why Olubowale Shongosoya was making these points was because he himself, or they themselves, let me not be biased, let me not be gender biased, they themselves are cybersecurity / IoT consultants. So you would want to connect with each other after the session. But ultimately, we've gotten to learn that like data is principle, whatever it is we're doing, and even if however it is we're communicating, from the highest scale to the most minute or the remote village, data is very important. That is how you're going to know what you're working with. That's how you're going to know how much money you'll be making. That's how you know if you would attract the investors you need to attract. Ideally, if you're having a physical dialogue, I was going to say after the session we could network, but I'm saying connect with everyone on LinkedIn, share your ideas, share your thoughts. Collaboration, as our panelists have mentioned, especially Mr. Warren, he laid a lot of emphasis on collaboration. Collaboration is how we get things done and how we move things forward. So thank you so much, everyone, for your time. Thank you for your wonderful questions. I'm deeply grateful on behalf of Next Year at the Electricity Hub. We are deeply grateful. Have a pleasant evening.
Thank you.
All right, thank you. Bye.
Thank you and good night.
Good night.